Okay, good day. This is AP Calculus. I am Mr. McCulley, and this is the presentation on Section 2.3, the product and quotient rules. I think I spelled those right. Okay, so today we're going to talk about taking the derivative of a function using the product rule, finding the derivative of a function using the quotient rule, and the mnemonic device that I use to do the quotient rule is Hody Hi minus Heidi Ho all over Ho Ho, and I'll go over that here in a moment. And then we are going to talk about the derivative of the other four trig functions. And finally, we are going to find higher order derivatives. And that just means the first, second, and third derivatives. And they're not that big of a deal. It's just the first derivative, you take a derivative, the second derivative, you take the derivative of the first derivative, and so forth and so on. So let's get on to it. There is a very short product rule calculus help video that you can watch and stop here. It is not by any means required. I am going to talk about the product rule in depth, but it does have a few nice animations that shows you how to get this particular rule that we're going to be talking about. So I'm going to give you a second to pause. 3, 2, 1. Okay, moving on. So whenever I have a function that is the product of two separate functions that I can say, and when I say product of two functions, they both have to have like a term of x in it. So this can't be a constant. I mean, it could, but you wouldn't use it. You use the constant rule from the previous lecture. So if you have the product of two functions, then the derivative of that is going to be the derivative of the first function times the second function plus the first function times the derivative of the second function. And the quotient rule, and again, I use the mnemonic device to remember it. It's Hody Hi minus Heidi Ho all over Ho Ho. And again, there is a calculus help video here at the bottom that you can use, and I'll put it in the description. And if you'd like to watch that quickly, it again has some nice little animations that help show you where the things go. And it's a little bit nicer than what I can do. So I'll give you a second to pause and do that. 3, 2, and 1. Moving on. So here's how I remember it. I call the top function high. So f of x is my high function. My bottom function is my ho function, and when I take the derivative of something, I call it d. So when you see that g is the bottom function, it is the ho function, and f is the top function, it is the high function, I can read this mnemonic device as ho, the bottom function, the derivative of the high function, the top function, minus the top function high times the derivative d of the bottom function ho all over ho times ho, which is ho squared. So if that helps, I hope it does. So I want to talk about taking the derivative of a trig function. And so we want to take the derivative of tangent x and learn the derivative of tangent x. And so just quickly, as a real quick review from the last one, remember, if I want to take the derivative with respect to x of the sine of x, that thing is just cosine x. If I want to take the derivative with respect to x of cosine x, we remember that that is equal to negative sine x. So tangent x is really the quotient of sine and cosine. And so we can rewrite this as d over dx, I haven't taken the derivative yet, of sine x over cosine x, which are two things that I know. That being said, if I'm using the product rule, ho d high, cosine is so I'm using the quotient rule here. Cosine is the bottom function, so it's cosine of x times the derivative of the top function. So the derivative of sine is cosine x minus high, the sine function, or sine of x, times, extend that a little bit, the derivative of the bottom, which would be negative sine x. And this is going to be all over ho ho, the denominator twice, or cosine squared x. And so this thing is cosine squared x minus sine squared x all over cosine squared x. Now, we have to remember from last year, oops, sorry, negative times a negative is a positive. So we have to remember a trig identity from last year, a Pythagorean identity that says cosine squared x plus sine squared x is equal to 1. So I can replace that with a 1. This is all over cosine squared x. And if you remember that 1 over cosine x is equal to secant x. So this particular derivative, this derivative here, is equal to secant squared x. And we're done. And so all of the other trig derivatives are based on a similar expression like this using the quotient and or the product rule. And so the other trig derivatives, one moment. Okay, the other trig derivatives, we just did this one. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant is secant x tangent x. And then the derivative of cosecant x is negative cosecant x cotangent x. And so those are derivatives that you probably need to put into your long-term memory for the AP Calculus test. Now, this is the last thing that I think I have to say before I start doing some examples here. And so for higher order derivatives, just kind of going through, this thing here is the first derivative. This one is the second derivative. This one is the third derivative, and this is the fourth derivative. Now they're going to ask you to do that, and so forth and so on. They're going to ask you to do that, but I haven't had a application of anything past the fourth derivative ever, even when I was doing my master's degree for mathematics. Never got past the fourth derivative, at least an application for that. And I've had to do more than a fourth derivative, and I don't think I'm ever going to ask you to do that, but I've never had an application. We definitely have applications for first and second derivatives, and might even have one for third later on if we get that far. Okay, so we are to our first example. And so I want to find the derivative of g. This is on page 126, number 42, finding the derivative of g. And this is definitely a quotient. And so my high function is going to be sine x. And then my whole function is going to be x to the third. So my first derivative with respect to x is going to be the whole function, x to the third, times the derivative of the top function, which is cosine x, minus so it'll be high d ho, so sine x times the derivative of the bottom function, which would be 3x squared. And then that will be all over x to the third squared, ho, because x to the third, x to the third. Now we can get a lot of this to cancel out, because I have x's here, I have x's here, and I have x's there. So if I start canceling, this is going to be x to the sixth, but I can cancel out an x squared from all four of those terms. So I will have x cosine x minus 3 sine x all over, and I'm taking out 2, so it'll be x to the fourth. Now, since I don't have anything common for all three terms, this is going to be my final answer, and it'll be okay like that. Okay, next example. So, find the derivative of y. So I look at this thing here, and it looks fairly simple enough. I've got this x sine x, and I have this cosine x. And again, we remember that the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. But, and this is one that a lot of people, they forget, and especially later on in the year. So we really want to get this down now. This right here is a product, and it is the product of x times sine x. So for me to do the derivative of this part, I have to use the product rule. So the derivative of x sine x must involve the product rule. Oh, let's try that one more time. There we go. Product rule. All right. So dy over dx, the first derivative. I take the derivative of the first, which is 1, and then I leave the second one alone, so it's just sine x, plus, leave the first one alone, cosine x, or cosine, times the derivative of the second, which would just be cosine x, plus the derivative of this cosine x, it's by itself. So this was the product rule, and then I take the derivative of this because of the sum and difference rules that we weren't learned in the last section. And so this is negative sine x. And so I have a positive sine x right here. I have a negative sine x right there. Those cancel, and I'm left with just x cosine x, and that is my final answer to that one. These two cancel. Alrighty, last one. And I'm sorry to do this, but I'm going to have to show you how to find the value of a derivative in class using the calculator. But here, sorry, needed another drink. We're going to do we're doing example number 122, and it actually asks 3 things, but I can only do the first one. It says find the equation of the tangent line at a point, and then use your calculator to find the value of the derivative at this point. So we want to find the equation of the tangent line, and I will show this in class, so please don't let me forget to do it. I'm sure one of you will be of complete giddiness and complete joy to remind me to do something. But anyway, I need to find the equation of a tangent line. The first thing I need to find is the slope of that line. So I got to find the slope first. And so to do that, we're going to find f prime, or the first derivative, of 2. And so again, I have a quotient, so let's do the quotient rule. So f prime of x is going to equal to ho d high, so ho is x plus 1. D high is just going to be 1, minus high x minus 1 times ho, which is just 1, all over ho, which would be x plus 1 quantity squared. Now we could spend a bunch of time simplifying this if we wanted to, and that's fine, but I can just go f prime of 2 and say that this is going to be, well, I'll get a 3 there, and it'll be minus, I'll get a 1 there, and then it'll be, let's see here, it'll be 3 squared. No, yeah, it'll be 3 squared, so it'll be 9 there. So I'll get 2/9 as my derivative of that particular function. And I think I did that right. Yeah, I'll be happy with that. So now, after I've done that, I said I'm going to use the slope and the point to find the equation of the tangent line. And so y minus y1 equaling to m times x minus x1. And so let's see here. I get y minus 1/3 will be equal to my slope, because this is my slope m right there, 2/9 times x minus 2. Ugh. So let's see here. When I distribute there, I'm going to get 2/9, and that's not, that looks more like an A. Let's see if I can be a little, yeah, that's a little bit better. It's going to be 2/9 x minus 4/9. Now I'll have y, but I need to change this to ninths so that I can add it to both sides. So this is going to change it to ninths, is going to be 3/9. And then so when I add it to both sides, I'll get y equaling to, let's see here, 2/9 x, it'll be minus 1/9. And that is the equation of my tangent line, which is the answer to part A. All right there, folks. Unless I made an algebra mistake or an arithmetic mistake in here, I think we are good to go. And so I am going to call it a day, and I will see you in class tomorrow. Have a great day. Goodbye.